If you discontinue watching this video at one point, please tell me what the reason for it was so that I can improve. Otherwise, I'm trying to learn biochemistry today, maintaining pH, buffer system, and after we've done that, we're going to do extensor carpi ulnaris strength training. That's here, at the lower arm. And if you participated in extensor carpi ulnaris strength training, then it's better the arm. Let's go. Maintaining pH, buffer system. Although the pH of body fluids may differ, the normal limits for the various fluids are generally quite narrow. Okay, we had it previously already. The body needs a pretty exact amount of pH, so amount of acidity to alkaline balance, very precisely. Homeostatic mechanisms maintain the pH of blood between 7.35 and 7.45, slightly more basic than pure water. Okay. Pure water has 7, there's the same amount of alkaline as acids in it, and 7 means it is balanced in the middle. 7 means pH 7 means there are 0 point, and then the 7th digit 0.000001 of 1 mole of acid inside of this thing, and the same amount now of alkaline. And 7.35 means there is now a little less in it, because it seems, I don't know how to calculate it, would be now 0.0000006 point something. They mean it's less. It's 7.35, so it's a bit less. It's not completely 8, it would be the 8th digit, so 0.0, and then 8 zeros and then 1, 7 zeros and then 1 of a mole, so it would be a little less acid in it. That means water is a little bit more basic. It has a little more basic, a little more alkaline than acid in it, or a little bit more alkaline than water is. Water is completely in the middle. Distilled pure water. Saliva is slightly acidic, and semen is slightly basic. Okay, we say saliva, there's a little bit more acid in, so it's a little below 7, and semen is like the blood a little above. Because the kidneys help remove excess acid from the body, urine... Okay, we're going to talk now about a few things. So we're going to talk about internal anatomy and also a few different body secretions. Because the kidneys help remove excess acid from the body, urine can be quite acidic. Before the urine goes from the kidneys to the bladder, the acid is... No, what was it? The kidneys are removing from the body and putting it into the urine, and therefore the urine is acidic. It has more acid in it. Even though strong acids and bases are continually taken into and formed by the body, the pH of fluids inside and outside cells remains almost constant. Okay, the human body takes all the time acids to them and also puts them out, bases and so on. But it must be pretty much exactly the same. Let's go over the table for a little moment to the table here. Gastric juices pH 1 to 3. They have a pH of 1, the gastric juices. Lemon juice 2. Vinegar 3. The gastric acids are 100-fold more acid in it than vinegar, and 300 times in, and 200. What is it? It's 1 and 2, so this would be 10. It's 100, yes. The gastric juices in the stomach are 10 times more acidity, have a 10 times more acidity than lemon, and 100 times more than vinegar. Orange juice 3.5, coffee 5, water 7, pancreatic juices 7, veal 7.5, and lye 14. Whatever it is. Okay. One important reason is the presence of buffer systems, which function to convert strong acids or bases into weak acids. Oh, what is it? But it means it's a buffer system, and the buffer system is not putting more alkaline in or bases out, it's just taking strong acids and making softer acids out of it. Convert strong acids or bases into weak acids or bases. Strong acids or bases ionize easily and contribute more H plus or OH minus to a solution. So the ions inside of these acids or the bases, if they are strong, are easily contributing the H plus or OH minus or the alkaline into the solution. And if you get more H plus into it, it gets more acidity. And if the body takes not quite easily the ions out of the OH minus out of the basics, you can get to it quite easily. You have no more alkaline and it gets less acidic. Therefore, they can change pH drastically, which can disrupt the body's metabolism. Okay, weak acids or bases do not ionize as much and contribute fewer H+, hence they have less effect on the pH. The chemical compounds that can convert strong acids or bases into weak ones are called buffers. Okay, there are some types of chemical compounds that are called buffers. And they can convert strong acids into weak acids and make it less acidic. One important buffer system in the body is the carbonic acid bicarbonate buffer system. Because carbonic acid H2CO3 can act as a weak acid, and the bicarbonate ion HCO3 can act as a weak base, this buffer system can compensate for either an excess or a shortage of H+. If you think of an evolutionary point of it, it sounds very simple, actually. It's just two substances and they happen to be able to be easier to make the jump to the other substance and the other one. It's from an evolutionary point of view, I think, very easy to happen. You just have a few examples and when happen to be that type of that and that can easily shift over to that element. That seems to be pretty simple, actually. It seems to be such a complex process that the pH is altered with having more acid and alkaline, but you just have to have a bit luck and have to have this acid and this acid so that it's able to jump from a strong acid to other acid because the ions are just easily jumping. But this more or less just a lottery and you just have to hit it that it are these elements which happen to do it. Because carbonic acid can act as a weak acid and the bicarbonate ion can act as a weak acid, this buffer system can compensate for either an excess or a shortage of H+. Okay, in the human body there are carbonic acid bicarbonate. Buffer is the carbonic acid bicarbonate buffer system. And there are carbonic acids, and these carbonic acids, they can be very easily a weak acid and very easily a weak base, making it very easily to use both. It's just to have one thing and you can use it to add something as to giving less on it. And there just happens to be the element carbonic acid in the universe, and if it happens to make its way into evolution, you just have to have that and you have the perfect thing. For example, if there is an excess of H+, an acidic condition, HCO3- can function as a weak base and remove the excess H+ as follows. We're having our H+, we don't want it, we have too much of H+. And we're having now our bicarbonate ion, our HCO3-, and it becomes carbonic acid, H2CO3. We're having H+ and now HCO3. So now we're having H2, we're having H+ and HCO3, and we're having now H2CO3. So H plus HCO3 gives 2H and CO3. And now we're having out of it H2O, water, we're having 2H and the O3 and carbon dioxide. We had H2CO3, so H2 stays H2O for water, H2 stays H2, and we had CO3, we had 3 O's. 1 O is in the water, H2O, that's 1 O, and 2 O's in the carbon dioxide, CO2. And we're having now the H2CO3, the C comes over to the CO2, and the O2 of the 3 O's come to the CO2. And that way we can make very easily out of too much hydrogen ions, H+, if we have our bicarbonate ion, our HCO3 carbonic acid, we're having H2CO3, and that can be just sweetened to water and carbon dioxide. And you can just get rid of them out of the human body. On the other hand, if there is a shortage of H plus and alkaline condition, H2Cl3 can function as a weak acid and provide needed H2 as follows. We are having H2Cl3 and we want now H2 and the HCO3 and we're getting again bicarbonate ion. And we can use it again for wherever we are. Okay, we're having our weak acid H2CO3 and that gives now one H and we're having still H left because we had H2, so H, C stays the same, it goes over, and O3, all O's can go over, the C goes over, the O goes all three over, and the H, one of them gets over to HCO3, one H stays, H plus, that is HCO3 is a minus, so the H plus stays, and that is our hydrogen ion, the acid. Buffers and the roles in maintaining acid-base balance are described in more detail in chapter 27. So the human body has bicarbonate ions or carbonic acid, maybe that's the same word. And that thing can, because the way it's composed, because it is, one page, HCO3, it is almost like water. H2O, HCO3 is almost H2O water. It's almost carbon dioxide, you can just breathe it out. CO2, HCO3, CO2. But it's also H plus because it has HCO3, it has an H, it can be H plus and we have acid. And so you can easily make it into water and carbon dioxide, and you can make out of it also an alkaline because you can make out of it an alkaline, more alkaline because you make it into water and carbon dioxide, and you can get acid if you want acid by taking the H and having just the bicarbonate left, but when you had to have the middle part, something like that. That is it, and that is how the body works. That was the biochemistry part. If you were here for biochemistry, you can go directly to the next part of biochemistry. If you stay here and participate in the extensor copper ion stress training, and it's a heavy task. We are having a good and still stance and having the hands and fists next to us. We bring the fists down, flex fists, and again up. We're having 3 rules. The first rule is that we're stopping immediately as soon as we feel pain. The second rule is that we're not overdoing it, that is the third one. The second rule is that we go only as far as we can go with a little bit of effort. Next exercise, hands, like that, and now up. Again, if there's pain, it's not really. Now, I'm using a sock, you could use a towel or a t-shirt as well. Press onto it and bring your wrist up. And again down. And up. Right, press, and up. And down. And next exercise, press evenly. And bring the hand to the supination to the outside. And press with all fingers evenly. All 5 fingers. We want to train the extensor carpi ulnaris. So press with the 4th and 5th finger. Outside again. And one more time inside. Alright. Press. Turn to the inside. And outside. One more time. And now take it from the top and bring your wrist down. And again up. Again down. Now your hand. Just press and bring your hand down. And now just press in neutral position. And away. That was the extensor carpi ulnaris strength training. Thank you very much and nice time.